So, have you ever made like a really small change to a critical system, maybe just updating one setting on a load balancer, and you get that chilling knot in your stomach,
Oh, yeah,
that kind of primal fear that just one tiny typo, one misplaced character could bring everything crashing down?
definitely. It's a feeling a lot of us know too well.
It's uniquely stressful, isn't it? And yet the demands on infrastructure teams today, they're just immense, supporting these incredibly complex deployments, huge scale, blinding speed. It feels like a contradiction sometimes.
It absolutely is. That tension, between needing to move fast and
Yeah.
the absolute need for stability, for reliability, that's really the challenge of modern IT, isn't it? The
Yeah.
traditional ways, the manual processes, they just can't handle it anymore.
Mhm.
Too much human error creeps in, they're way too slow, and they definitely don't scale when you're dealing with hundreds of services, maybe thousands if you count everything a cloud provider offers.
So how do you fix that? How do you not just bridge that gap, but really get rid of that anxiety, streamline everything, make it consistent, but without losing speed?
Right.
That's the big question we're tackling today. This deep dive, it's all about GitOps and infrastructure as code, or IAC. These are really powerful ideas, concepts that are fundamentally changing how we build and manage IT infrastructure applications, the whole lot.
Yeah, and our mission today is really to get past the buzzwords,
Yeah.
to really unpack what GitOps and IAC actually are. We'll look at how we got here, the evolution, the core ideas behind them, the frankly huge benefits they offer, and then some practical ways to actually do it using tools like, say, Terraform.
Okay.
The goal is that by the end, you'll have a really solid handle on this shift and maybe think a bit differently about your own infrastructure challenges.
Right. We've all seen the progression, haven't we? I mean, we remember the days of ClickOps or SSHing into servers, manually setting things up, configuring them one by
And
one.
yeah, the good old days.
Painstaking, wasn't it? So error-prone and almost impossible to replicate perfectly every time. Then infrastructure as code came along as this, like, revolutionary answer. But you're saying its real genius wasn't just the code part.
That's a great point.
Yeah.
Because it really was more than just scripting or automation. IOC was a shift away from imperative commands,
Hmm.
telling the system exactly how to do something step by step by step.
Okay.
It moved towards declarative states,
Yeah.
where you just describe the desired end state of your infrastructure,
Yeah.
what you want it to look like.
Oh, okay.
So instead of manually clicking or scripting every server, every network rule, every database setting,
Right.
you define the whole environment in these machine-readable files, code, essentially.
Right.
And then the tools, they figure out the how to make the reality match your declared state. That leap in thinking,
Yeah.
that was the crucial bit.
So it's not just automating the old manual steps. It's fundamentally changing how we describe our infrastructure in the first place. And this didn't happen overnight, right? It evolved in stages. From just configuring servers to managing whole cloud setups across different providers.
Precisely. Yeah, you saw first-gen tools like Puppet and Chef. They were mostly focused on configuring servers that were already up and running.
Mm-hmm.
Then came the next wave, Ansible, SaltStack. They could often provision the VMs before configuring them. So a step further.
Okay.
Then, as cloud really took off, you got the cloud-specific tools, think AWS CloudFormation, Azure Resource Manager. They let you describe whole application architectures in JSON or YAML. But, they were tied to their specific cloud.
Locked in.
Exactly, which naturally created the need for multi-cloud tools. And that's where something like Terraform really came into its own.
Right.
Terraform kind of abstracted away the specifics of AWS versus Azure versus Google Cloud, even on-prem. It gave you this like universal language to define your environment once and deploy it pretty much anywhere.
That universality, that's huge. And the main benefit isn't just raw speed, is it? It's the consistency, predictability.
Exactly.
No more of that infrastructure drift where your live system slowly gets out of sync with what you think it's supposed to be.
Right, that drift is a killer.
And numbers back this up, right? Organizations using IAC, they report much higher performance, faster development cycles. But okay, even with great IAC tools, you still need a solid workflow to put that code into action automatically, reliably. And that's where GitOps steps in.
That's exactly where the two ideas really connect and amplify each other. GitOps, it's a term Weaveworks coined back in 2017. It basically provides that missing prescriptive workflow. It takes Git, which, let's face it, is everywhere for version control.
Mhm. The standard.
Yeah, the de facto standard, and combines it with operations management. The core idea is making Git the single source of truth for everything related to managing your infrastructure and your application deployments.
Okay.
It really took off initially with Kubernetes, but the principles, they apply much more broadly now.
So it goes beyond just infrastructure as code. It's more like an everything as code vision, where documentation, monitoring config, build pipelines, it all lives in Git alongside the actual application code. I think Spotify's approach is often mentioned here.
Yeah, that's a great example. That holistic view is absolutely key. And GitOps is built on four fundamental principles. First, the entire system is described declaratively.
Which we touched on with IAC.
Exactly. You define the desired end state, the what, not the how. This makes the whole system inherently more robust, easier to understand. If you know what it should look like, figuring out why it doesn't becomes much easier.
Makes sense. Okay, principle one, declarative. What's next?
Second, that desired system state is versioned in Git. Everything, your infrastructure definitions, your application code, configs, it's all stored and versioned in Git.
Right.
And this isn't just for backup. It gives you a full, chronological, auditable history of every single change. It's basically your undo button for the entire infrastructure.
Ah, nice.
Something goes wrong, you could roll back to a previous known good state almost instantly. Plus, you get things like signed commits in Git, which boosts security by proving who made a change and that it hasn't been tampered with.
Okay, so declarative version in Git. What's principle three?
3. Approved changes are automatically applied to the system. Once your team reviews and merges a change in Git, usually via a pull request or merge request process,
Standard practice.
right, standard developer workflow, the system automatically pulls that change and applies it to the target environment. GitOps really favors this automated pull-based approach over manual pushes or interventions.
Okay, automatic application. And the fourth one. This sounds like the real core of it.
It really is. The fourth principle is that the system state is continuously reconciled. There's a specialized piece of software, a GitOps operator or agent. Common ones are Argo CD or Flux CD that's constantly watching.
What?
It's watching the actual state of your live environment and comparing it nonstop against the desired state defined in Git. If it sees any difference, what we call configuration drift,
Right, that drift again.
yeah, it automatically takes action. It orchestrates the underlying infrastructure, whatever is needed, to bring the live state back into line with the desired state from Git.
Wow.
So it's not just storing your config in Git, it's actively enforcing that reality matches the code all the time.
It's like a self-healing system.
Pretty much, yeah. It's constantly course correcting.
Okay, so we've laid out what the principles of GitOps, but let's talk about the so what. For you listening, what does adopting GitOps actually mean day to day? What are those real, tangible benefits?
Well, the impact is pretty huge, honestly, both for developers and for the ops teams. For developers, it's just a much, much better experience.
How so?
They get to use the tools they already know and love, Git, pull requests for managing infrastructure. They don't have to learn a bunch of complex cloud-specific commands or APIs nearly as much.
Less context switching.
Exactly. They can focus more on writing the application code, the features, not wrestling with infrastructure setup, and think about onboarding a new developer can get up to speed and become productive way faster.
That really hits on the productivity angle we keep hearing about. It
Yeah.
kind of democratizes the infrastructure, doesn't it?
It does.
With IAC providing the templates and GitOps handling the deployment, developers can essentially spin up their own environments when they need them. Self-service.
Right. Self-service is a big part of it. And crucially, because it's all code in Git, infrastructure changes go through the exact same code review process as application code.
Good point. Peer review for infra.
Yes. Which catches errors like, accidentally trying to spin up a monster, super expensive database cluster.
Been there.
We all have. And it fosters real collaboration between dev and ops because they're looking at the same artifacts using the same process.
Okay, so big wins for developers. What about the ops side?
For operations, infrastructure management just becomes much more streamlined. It's integrated right into the standard CI/CD pipeline and DevOps process. This directly boosts productivity and efficiency.
Yeah.
We see stats all the time. Surveys showing teams using these practices report, significant improvements in how efficiently they work.
And I imagine reliability and stability get a massive boost too.
Absolutely massive, because everything's version controlled, it's declarative. The chance of human error causing an outage just plummets. That configuration drift we talked about,
Yeah.
it gets spotted and fixed automatically, often before anyone even notices. And if something does go wrong, a bad deployment, a misconfiguration slips through review somehow.
Right.
The ability to roll back to the last known good state, which is right there in your Git history, in minutes, instead of hours of panic searching and manual fixes, that's a complete game changer for incident response.
I can see that. What about things like audits and compliance?
Oh, huge wins there too. Every single change to your infrastructure is logged in Git. You have an immutable, crystal clear audit trail.
Hmm.
Who changed what, when they changed it, why they changed it, from the commit message or PR, and exactly what resources were affected.
Makes audits much less painful.
Infinitely less painful. And for disaster recovery, your entire infrastructure definition lives in Git. You can, in theory, recreate everything from scratch relatively quickly just from that single source of truth.
And security, you mentioned that earlier.
Yeah, security posture improves significantly. Typically, developers don't need direct privileged access or credentials for production environments anymore.
How does that work?
Access is controlled through the automation. The CI/CD pipeline or the GitOps operator is what interacts with the infrastructure based on approved code changes in Git. This drastically shrinks the attack surface. Fewer humans with direct access means fewer potential points of failure or compromise.
Reduces the blast radius, too, if something does get compromised.
Exactly. And overall, GitOps pushes you towards standardization. Consistent workflows, consistent code structure, documentation, testing. It all leads to infrastructure that's fully reproducible.
And all of this adds up to speed and agility, right?
Ultimately, yes.
Hmm.
Automated deployments happen faster, more frequently, more reliably. This enables much more rapid, agile development cycles. I mean, think about the example of updating, say, tens of thousands of telecom towers without anyone having to manually log into anything. That's the kind of scale and speed GitOps enables.
That's pretty incredible. Okay, so that's a compelling vision. For teams listening who are thinking, right, I want some of that, what are the key tools you need in the GitOps world? And maybe some best practices for actually putting this into action effectively?
Sure. Well, the ecosystem's quite mature now. For your Git repositories themselves, you've got all the usual suspects: GitHub, GitLab, Bitbucket, Azure Repos, AWS Code Commit. Basically, any modern Git provider works.
Okay, Git is foundational. What about the IAC layer?
For infrastructure as code, we mentioned Terraform, which is super popular, especially for its multi-cloud support. But you also have AWS CloudFormation, the AWS Cloud Development Kit, or CDK. Ansible is still used a lot. There are options depending on your stack and preferences.
And for orchestrating all this, you mentioned Kubernetes.
Yeah, Kubernetes is a very natural fit for GitOps. Its whole model is based on declarative YAML manifest defining desired state, and it deals with containers which are typically immutable. So it aligns really well. Docker Swarm is another possibility in the container space.
And the glue holding it together, the CI/CD.
Right, your CI/CD platform is crucial for automating the build, test, and sometimes the trigger for the GitOps workflow. So Jenkins, CircleCI, GitLab CI/CD, GitHub Actions, AWS Code Pipeline. Again, lots of mature choices there.
And then the special sauce, the GitOps operators.
Exactly. These are the engines that do the continuous reconciliation. Argo CD and Flux CD are probably the two best known. Both are graduated projects in the Cloud Native Computing Foundation, which is a good sign of maturity and community support. They're the bits that constantly compare Git with reality.
Let's zoom in on Terraform for a second, since it's so common. You mentioned its configuration language, HCL. It uses these blocks like provider, resource, data. What makes it powerful in practice?
Yeah, HCL is designed to be human-readable, but also structured for machines. The declarative nature is key. You say what you want, not how to get it step by step. This leads to idempotency of running it multiple times, has the same end result, and allows Terraform to figure out dependencies and even run things in parallel. And the dry run capability is vital.
But maybe the most distinctive Terraform concept is the state file, right? Terraform.tfstate.
Absolutely. The state file is Terraform's memory. It keeps track of the actual resources it manages in the real world, mapping them back to your configuration files. When you run Terraform, it reads your config, compares it to the current state recorded in that file, figures out the difference, what needs to be created, updated, or destroyed, and then it makes the changes and updates the state file.
And for teams, managing that state file is critical.
Oh, absolutely crucial. You cannot just keep it on your laptop if you're working in a team. You need to use a remote backend store, the state file, centrally and securely, like in an S3 bucket, Azure Blob Storage, or using Terraform Cloud. This prevents multiple people from accidentally trampling on each other's changes and ensures everyone's working from the same picture of reality.
Got it. And that plan and apply cycle you mentioned, that seems core to using it safely.
It really is. Running Terraform plan first is best practice. It gives you a detailed preview. If you run apply, here's exactly what I will do. No changes are made yet.
Like a safety check.
Precisely. You review that plan, make sure it looks right, maybe get a teammate to double check it. Only when you're confident do you run Terraform apply, which actually executes the changes, and usually it asks for confirmation one last time. It makes infrastructure changes much less terrifying.
And you mentioned modules earlier. How do they help?
Modules are basically reusable chunks of Terraform code. As your infrastructure grows, you'll find yourself repeating patterns, maybe how you set up a standard web server or a database cluster. Modules let you package that configuration up, give it some inputs, and then reuse it easily. It keeps your main configuration clean, promotes standardization, and makes things much easier to manage. There's even a public Terraform registry with tons of pre-built modules you can use.
Okay, so we have the tools. Now let's talk best practices for actually implementing a GitOps workflow. What are the key things to get right?
Right, the practicalities. First, a big one. Try to define all your infrastructure as config files, even the small, seemingly insignificant bits.
Why everything?
Because anything left out becomes technical debt.
Yeah.
It's outside your version control, outside your automated process. It's often an iterative process. You might not get everything on day one, but that should be the goal. And if there are things you genuinely cannot automate, maybe legacy systems, manual steps involving third parties, then document them religiously. Make that documentation live alongside your code, maybe even in the Git repo.
Visibility is key.
Okay, what else? You absolutely need a robust code review and merge request process for infrastructure changes. Treat infra code with the same seriousness as application code. Get your teams comfortable with Git, set clear guidelines, maybe require approvals from specific people or teams. This is your main quality gate.
Makes sense. Error prevention.
Yeah. Also, definitely think about multiple environments. You'll likely have dev, test, staging, prod, the classic DTAP model, or something similar.
Right.
You need a strategy for managing configurations across these environments and ensuring your code in Git accurately reflects what's running everywhere. Tools that can detect diffs or drift between Git and the live environment, like Kubernetes or Terraform, can be really helpful here.
And you mentioned limiting direct access earlier.
Yes, another critical practice. Make your CI/CD pipeline the main, ideally the only, access point to your infrastructure resources. Shift the mindset from, I need credentials to do my job, to the automation has access because it needs to do its job based on my approved code. It's a fundamental security and reliability improvement.
That's a big cultural shift for some places.
It can be, absolutely. You also need to figure out your repository strategy. Do you put all your infrastructure code in one big monorepo? Or split it into multiple repositories, maybe per team, per service, per environment?
Pros and cons to each.
Yeah, there are trade-offs around visibility, blast radius ownership, pipeline complexity. There's no single right answer. It depends on your org. But one really crucial point here, often considered an anti-pattern if you get it wrong. Try to decouple your application lifecycle from your infrastructure lifecycle.
Meaning?
Don't tie application deployments directly to infrastructure changes in the same pipeline or repo if you can avoid it. They often have different cadences, different concerns. Managing them together can get very messy very quickly. Think about versioning your infrastructure modules independently, maybe using semantic versioning.
Okay, decouple app and infra lifecycles. Good tip. Anything else?
Keep your changes small. Small incremental pull requests are much easier to review, easier to understand, easier to roll back if needed, and give you faster feedback. And finally, validate your infrastructure code early and often. Integrate linting tools, static analysis, and things like Terraform validate right into your CI pipeline.
Fail fast.
Exactly. Fail the build immediately if the code is invalid. Don't let bad code even get close to being applied. Notify the team straight away.
Makes total sense. And you made a really strong point earlier. You can't do GitOps without observability. Why is that so fundamental?
Right. It's the essential feedback loop. Without it, the whole system is flying blind.
Can you break that down? What kind of observability are we talking about?
Well, there are really two sides to it. First, there's internal observability. This is about the GitOps controller itself, your Argo CD or Flux CD. It needs visibility into the actual current state of the cluster or environment it's managing.
How does it get that?
Through logs, metrics, traces generated within that environment. It uses this information to constantly compare the actual state to the desired state defined in Git. If it sees a mismatch, that diff alert we talked about, that's its trigger to act to reconcile the states. Without that internal view, it can't detect drift or know when to self-correct.
Okay, so internal observability lets the system see itself and fix itself. What's the other side?
The other side is external observability. This is about making sure that other systems, and crucially your human operations staff, know what the GitOps system is doing.
Ah, telling the humans.
Exactly. The GitOps controllers should publish their own metrics. I just sync this application, I detected drift here, I'm reconciling now. These metrics can then be scraped by your main monitoring systems, like Prometheus.
Why is that important?
It gives everyone context. It prevents your monitoring system from firing off noisy, unnecessary alerts just because the GitOps tool is doing its job making a planned change. It provides that heads up. Oh, okay, Argo CD is deploying a new version. That's why pod counts are changing. It reduces alert fatigue and helps operators understand what's happening automatically versus what might be a genuine problem.
So internal observability lets the system manage itself. External observability lets humans understand the system.
Got it. It really ties everything
It
together.
really does. It completes the loop and makes the whole process trustworthy and transparent.
Okay, well, this has been fascinating. This deep dive has really shown how GitOps takes what used to be this manual, often terrifying process of infrastructure management and turns it into something streamlined, automated, and frankly, much more reliable.
It's this declarative, version-controlled approach using tools we already know, like Git, and it delivers huge benefits: speed, consistency, better security, and way fewer of those heart-stopping errors. It feels like more than just tools, it's really a different philosophy for running modern IT.
It really is a paradigm shift. And maybe as a final thought to leave everyone with, if GitOps proves we can reliably manage complex global infrastructure by treating everything as code, the infra, the apps, the policies, the docs, what else could we apply this to?
Hmm.
What other parts of our work, maybe even outside of tech, could be codified, version controlled, and managed with these principles of declarative state and continuous reconciliation? Think beyond infrastructure. What if even knowledge management or complex project plans could benefit from this kind of rigorous, automated, auditable approach?
Mm.
It makes you wonder what else we could bring under this kind of reliable control.